Hello, I am Shai Kumar Dhar. Today I am going to give a complete speech on differentiation for class 11 and 12. Okay, first of all, we should know what is differentiation. Differentiation is nothing but a limit. It's defined as follows. If I say differentiation of a function f, okay. First of all, we should check a function is whether differentiable or not at some point. Okay, like I am checking a function to be differentiable or not at a point A. A function f is said to be differentiable at x equals to a if, what is the condition? The condition is limit h tends to 0 f of a plus h minus fa by h exists. A function f(x) is said to be differentiable if this limit exists, and differentiation, the value of its derivative, it is f dash a. It can be written as f dash a, that is a plus h minus fa by h. If this exists, then the derivative at the point A is defined as this, and it is denoted by f dash a, or it can be written like d by dx of fx at the point A. It can be written like that also, d by dx of fx at the point x equals to a. Okay, so it is the definition of derivative. So if a function is going to be differentiable, then this limit should be exists, and the limit, the value of its limit will be its value of differentiation at that point. Fine. So, and this definition is called first principle of derivative. This definition is called first principle of derivative or differentiation. Derivative and differentiation both are same term. Okay. Now with using this formula, I am going to solve a differentiation. Okay. If fx equals to like e to the power x. Okay. So by using that formula, I am finding its derivative. How? I am finding its derivative on any arbitrary point x. So by that formula, f dash x will be limit h tends to 0 f of, there I used f of a plus h minus fa by h. Here my a is x, so it will be f of x plus h minus fx by h. Fine. So what will be its value? Now it will be limit h tends to 0 f of x plus h. So I will just replace x with x plus h. So it will be x plus e to the power x plus h minus e to the power x by h. So its value will be limit h tends to 0. It can be written as e to the power x into e to the power h minus e to the power x by h. Fine. So now h tends to 0. I can take e to the power x as common, then it will give me like this. Fine. Now this term is constant here because here only variable term is h. Okay, so I can take it So I am making it there e to the power x, and it can be written like this. Okay, then what is its value? What is value of this limit? It was a formula, well-known formula. It goes to 1. It goes to 1. So it will be e to the power x into 1, and it will be e to the power x. So the differentiation at the point x is e to the power x for the function e to the power x. So for function e to the power x, f dash x is e to the power x itself. Okay. So using this formula, I can find differentiation of any function. Now I am writing the differentiation of various well-known functions. You should note it just like it is differentiation formulas. Okay, just like if fx is e to the power x, like I am writing it like this. Okay, I am writing it like this: d by dx of e to the power x, that is e to the power x, d by dx of x, that is 1. Okay, d by dx of x to the power n, that is n x to the power n minus 1, d by dx of log x, that is 1 by x, d by dx of 1 by x, that is minus 1 by x square, d by dx of root x, that will be 1 by 2 root x. Now d by dx of a to the power x, it will be a to the power x log e base a. Okay, d by dx of sin x, that is cos x, d by dx of cos x, that is minus sin x, d by dx of tan x, that is sec square x, d by dx of cot x, that is minus cosec square x, d by dx of sec x, that is sec x into tan x, and at last but not least, d by dx of cosec x, that is minus cosec x cot x. Okay, these are the formulas that we use. This is ready-made formulas. By this I can find the derivative so fast. Okay, please note it down. I am erasing this. Now take a question, that is, if fx is looking like mod x, is f differentiable at x equals to 0? This is my question. So by which way I can solve it? Just go to the first principle, that is its definition. Limit, the point is x equals to 0, so this is my a. Okay, so it will be limit h tends to 0, f of a plus h, this is f of 0 plus h minus f of a, it means f of 0 by h. Okay, what it will be now? It will be like limit h tends to 0, f of 0 plus h means fh minus f0 means 0 by h, limit h tends to 0, fh means mod h by h. Fine, and at h tends to 0, I have to check, does this limit exist or not? So by which way I can check a limit exists or not? I have to check its left hand limit, I have to check its right hand limit. If both are equal, then if the limit exists. If both are not equal, then limit doesn't exist. So I have to check limit h tends to 0 minus mod h by h, and limit h tends to 0 plus mod h by h. I have to check this. So what will be mod h by h? When h tends to 0 minus, it is negative. When x is negative, what is the mod function? Mod function is defined as mod x equals to minus x if x less than 0, equals to x if x greater than equals to 0. Okay, so if h tends to 0 minus, so it will little negative, so then mod h will be minus h by h, so it will be minus 1. And for this one, limit h tends to 0, in this case h is 0 plus, so it is little positive. That's why in this case mod h, in this case this is mod h by h, basically mod h by h. In this case mod h is positive h, so it will be h by h by this definition. So it will be h by h, it is 1. So in this case limit h tends to 0 minus is coming minus 1, and limit h tends to 0 plus, it is coming 1. Both are not equal. That's why this limit, it means this limit does not exist. This limit does not exist. If this limit doesn't exist, it means the differentiation of fx at x equals to 0 doesn't exist. Clear? Fine. And I am also saying you a very beautiful and link, differentiations link with limit and continuity. It means differentiable, it means continuous, it implies limit exists. But if limit doesn't exist, then it can't be continuous, it can't be differentiable. If limit doesn't exist, then it can't be continuous and it can't be differentiable at all. Okay. But if a function is differentiable, then it must be continuous and its limit must exist on that point. Fine. It's a very well-known thing and a very important thing also. Now, I'm going to a particular type of differentiation that is called UV method. Okay. It's like u and v are two functions, f of uv, where ux and vx, these are two functions. Okay. Then f of d by dx of its derivative, it is basically derivative of uv, two functions. If two functions are in product, then its derivative will be d by dx of ux. In that case vx will be there fixed, and if you take ux fixed, then d by dx of vx. It's nothing but just make one function constant and derivative of another one, and next that function constant and derivative of the other one. Okay, this is the derivative of product of two functions. If derivative of u by v, two functions where ux and vx, they are the two functions. Okay, two function of x, both are function of x, ux and vx. Then d by x of u by v, what is the formula? The formula is v square, and on the upper hand it will be v into du by dx minus u into dv by dx. These two are the formula. By using these two formula, I am solving two problems now. Okay. And there are very special thing. It comes from this one. It is d by dx of c into fx. Its derivative. D by dx of c into fx. What will be? It will be c into f dash x. Okay. The constant where c is constant. This c is constant. Then constant will go outside, and it will be d by dx of fx. It means f dash x. Okay. Fine. It's basically come from this one. Okay. If I have missed to tell you that, then please notice it. D by dx of any constant function, d by dx of any constant, that is 0. Then this thing come from this function, from this thing comes from this one. How? D by dx of this thing, by this formula, it will be keeping the first one, I am keeping the first one constant or second one constant. I am keeping this second one constant fixed and derivative of first one. I am keeping the second one fixed and derivative of first one. It will be d by dx of c plus I am keeping the first one fixed and d by dx of second one. Okay. Then what will be this? D by dx of c, it is constant, it is 0 by this. So it will be fx into 0 plus it will be c into d by dx of fx. It means f dash x. Something into 0 equals to 0. So 0 plus c into f dash x. It is c into f dash x. So it has come. It can be proved by this formula, UV method. Okay. I am doing two problems on this. One from UV method and one from U by V method. Okay. Just do it. Like, if your fx is x square e to the power x, what will you do? Then it is, you will do it by UV method. It is your u and take it is your v. Okay. Take it is as u, take it is as v. Okay. Then my formula, f dash x, it means d by dx of fx. What it will be? It means d by dx of x squared e to the power x. Then what is your task? Just first time you can fix anything. You can fix anyone. I am fixing first time x squared. Okay. I am keeping this one fixed. I am keeping this one fixed and d by dx of second one. Okay. D by dx of v, it means second one, e to the power x. And on the second time, I am keeping e to the power x fixed and d by dx of the first one, it is x square. Okay. D by dx of x square. So what we have done, first time I have kept x square fixed and d by dx of e to the power x, plus I have kept second one fixed, e to the power x fixed, and d by dx of the first one, it is x square. Done. This is the form. So it will be x square into d by dx of e to the power x. By formula it is e to the power x, and it is e to the power x into d by dx of x square. This is 2x. Okay. So it will be, basically if I take common x e to the power x, it will be x plus 2. Fine. This is my derivative. I have done. Now I am doing u by v method. Okay. I am taking a function like this. Let fx equals to sin x plus x by e to the power x. Okay. This is my function. Then what will I do? Just then d by dx of fx will be, then this is the upper thing, this is my u, this one is my v. Okay. It is basically u by v. It is basically in the form u by v. Then what is the rule? The rule is, in the denominator it will be v square. What is v? It is my v. So it's square. So it's basically e to the power x square. And on the numerator, v into du by dx. So it is my v, e to the power x, into du by dx. It is d by dx of u. U means sin x plus x minus u into dv by dx. What is my u? This is my u. So it will be sin x plus x into d by dx of v. So it means d by dx of e to the power x. Okay. Now just simplify and use the formula of differentiation. E to the power x into d by dx of sin x plus x. D by dx just breaks. Just if there is a plus sign or minus sign, it's just distribute, because it can be written as d by dx of sin x. It can be written as d by dx of sin x plus d by dx of x. Okay. Plus d by dx of x minus sin x plus x into d by dx of e to the power x. What is its value? Its value is e to the power x by e to the power x square. It means e to the power 2x. So it will be e to the power x. I can take it as common. Okay. So e to the power x. So no, I'm not taking it as common. I'm basically, there will be a bracket. What I have missed. There will be a bracket because e to the power x is common with this whole thing. E to the power x is common with whole this thing. Okay. And this is distributed here. So e to the power x should be common with both. Okay. I am now taking e to the power x common from this and from this both. Okay. So it will be now e to the power x common, d by dx of sin x is cos x plus this is 1. Okay. Minus, I am taking minus in the same bracket. Okay. Minus sin x minus x. Okay. By e to the power 2x. It means e to the power x into e to the power x. Okay. So these two will be vanished and it will be like cos x minus sin x minus x plus 1 by e to the power x. This is my answer. Fine. Okay. Now I'm going to tell very interesting thing that's called chain rule in derivative. That's called chain rule in derivative. That is, if you want to, there is two functions. Okay. Fx and gx. Okay. And you want to make derivative of, it is d by dx of f of gx. Okay. Then what will you do? You do one thing. Okay. You do just f dashed gx into g dash x. This is a very formulatic and explicit thing. You might not understand from this one, but from what I am going to tell now, you can easily understand this. Okay. I am taking an example just I am taking an example. I am taking an example like, if your function is given by fx equals to just like e to the power x square. Okay, this is my function. I have to differentiate this thing. How will you do it? Then f dash x, it is d by dx of fx. You can write it like this also, d by dx of fx. It means d by dx of e to the power x square. Okay. Now your work is just break it. Take it as x. Just assume this x square as x. If you assume this as x, then what you will do that? If you assume x square as x, then it will be like e to the power x. So what will is derivative? Derivative of e to the power x is e to the power x itself. So that will be e to the power x. You have assumed x as x square. So e to the power x square. And now what you have assumed as x? X square. So now you multiply the derivative of x square. You multiply derivative of x square. Okay. So it will be e to the power x square into derivative of x square is 2x. This is your answer. Okay. I am taking another example. Okay. Take another example. Sin 3x plus 5. Okay. Derivative. Make derivative of this one. How will we do that? Take this one. Take this one as x. Okay. Take 3x plus 5 as x. Then how this function will look like? This will look like then sin x. What is the derivative of sin x? Cos x. So it will be cos x. Now what have you assumed as x? 3x plus 5. So it will be cos of 3x plus 5. Now which thing you have assumed as x? Now derivative that one and multiply it. So it will be multiplied with this thing. This thing you have assumed as x. So now derivative this thing. It is d by dx of 3x plus 5 and multiply it with this one. Okay, it will be like into what is derivative of it? Its derivative is 3. Okay, so it will be basically I can take it this 3 into forward and it will be like this. Okay, I think you all have understood. Now I am taking another beautiful examples, another 2 beautiful examples for chain rule method. I am doing basically chain rule. Okay, take 2 examples, just like take this one. Take this one. Okay, what will be its derivative? D by dx of this one. How can you make it? Okay, so it will be, now take this thing as x. Take this thing as x. So now, what is your formula? D by dx of ax is a to the power x log e base a. Okay, this is like your a, this is like a. Okay, so it will be a to the power x log a. You have assumed this thing as x. So a to the power x log a. So your x means this thing, x square plus 2x a to the power x into log a. Log e base a. What is your a? A is 3. Now we have to multiply. What we have to multiply? We have to multiply the derivative of that thing which you have assumed as x. You have assumed it as x, this one. Okay. So you have to you have to find derivative of this one and multiply it with this thing. Here, now its derivative of x square plus 2x. Fine. So it will be 3 into x square plus 2x into log e base 3 into its derivative will be 2x plus 2. And this is my answer. I can make 2 as common from this one. Then it will be looking like 2 into x plus 1. Fine. Okay. So this will be my answer. For your convenience, I am also doing another. Okay, just look at this. I am giving you another example to understand this very well. I am making e to the power 10x. Okay, this is your function. Make d by dx of e to the power 10x. What will you do? Take this function again. Take this thing as x. Take this as x. Okay. So now basically it is in the form e to the power x. What is its derivative? What is its derivative? Its derivative is e to the power x. Okay. So what will be its derivative? Its derivative will also be e to the power x. But now my x is 10x. I have assumed x as 10x. So it will be e to the power 10x. Now, which I have assumed as x, that is 10x. Then I have to multiply the derivative of 10x. So I have to multiply d by dx of 10x. So it will be e to the power 10x into d by dx of 10x, that is sec square x. So it's basically sec square x 10x. So I think you all have clearly understood. So I am ending this class here. And to learn more about this and to watch more videos, please subscribe, like and share. On the next time, I will discuss more examples of differentiations. Okay.